So a little bit of homework help. I've already kind of pre-did some of this stuff for you. So the first part of this is getting your half-lives. You got 239 PU. You're going to be using your half-life equation, T1/2 equals 0.693 over K. My K comes from what was given in the formula, which is 24,630. When I do the math there, I get 2.845 E negative 5, year negative 1. And I need to go ahead and convert that over 2 seconds. And my conversion factor for 1 year to seconds is 315,36000. When I put that in, I get 9.02 E negative 13 S negative 1. Okay. Now, I do the same thing with 241 PU. T1/2 equals 0.693 over K. I have 0.693 over 13. I went ahead and just put in the conversion factor down below to get it to seconds, negative 1, so I can compare back. Now, you can go ahead and do that, leave it as years, negative 1, and then convert if you like. Because I will tell you later on in the bottom problem, I need it back in years. And so I end up having to reconvert it again to get it back to years, which is this number here. Okay, and so the next question asks which one decays more rapidly, and it's 241 PU. So now let's get down to part C, which is more challenging. So the first thing is it uses the equation rate equals Kn, which was an equation we briefly talked about. We didn't get to really practice in class. Okay, no worries. So the K comes from up above. We solved for that. That's the 1.7 times 10 negative 9. And then the 1.24 e to the 22nd, well, that's what's in red right here. So I take the 5 grams and I'm going to convert it over from grams to atoms. So my grams is 241. That equals 1 mole. And then I use Avogadro's number. 1 mole is 6.02 times 10 to the 23rd. And I get 1.24 times 10 to the 22nd. Okay. So I'm going to slide that number in. And now I'm going to get my rate. So my rate, when I take the K times the N, is 2.10 times 10 to the 13th. Okay. And that's disintegrations per second. All right, new part. Because the other half of the problem says what mass of 241 PU is left after 1 year, 10 year, and 100 years. All right, so now I'm going to go back to my equation. Natural log A naught over AT equals negative KT. And if you look at my notes, I kind of goofed on that and put A naught on top, A naught on bottom. But it's corrected here. So when I expand my equation out, then I get natural log AT minus natural log A naught equals negative KT. Now I'm solving for this. So I'm going to have natural log AT equals negative KT plus natural log A naught. Okay. Now that we have that, let's just put in our numbers and solve. I think you're going to see where we're going with this, with it in this form. Okay, so I'm going to solve for the very first one, AT, and this is going to be my 1 year. Okay, I'm going to put out here 1 year. And so, remember I mentioned about that the K, you could go ahead and leave it in year negative 1 because you're going to need it at the bottom. Well, this is where we need that. So this is where I mentioned I converted it back, and I'm using this number here. So we get 0.0533, year negative 1. My time is 1 year plus natural log. And our A naught is going to be the 5.0. Because that was our initial. So when you put that in, we'll end up with natural log AT, and I get 3 times 1.0 plus natural log 5.0 and I get, for this part here, I'm getting a 1.55. And so I'm going to go back to my calculator and just remind you that you do second natural log, and then we are going to put in that 1.556, and I get 4.7 grams. So my AT equals 4.73 grams. Okay. So I'm going to use the same process again. There's no change. And I'm just going to do natural log AT equals negative 0.0533. And this time it's 10 years plus natural log 5.0. And I'll leave that to you to solve, as you saw in my notes. Real quick thinking here, it's got to be less than 4.7. And so I will tell you that for the 10 year, hopefully you get 2.9 grams. And then when you do the 100 year, it's got to be much, much less. And hopefully you get like 0.024 grams. Okay. And that's your homework help.